master. Okay, the master functionality is a subset of full required ASP master functionality. So in wait state, actually they are trying to implement one protocol checker for the ASP module, right? So in order to implement that protocol checker, they are using one always block. Okay, so this always block will always work with respect to clock. Okay, so whenever you are getting wait conditions, so during that time you should get 1 here, and other time you should get 0 0. So that is what they are trying to check. They are trying to check this condition. Okay, whenever you are getting wait condition. So for that, how they are modeling, you say always at b wait. So whenever b wait, there is a change in b wait, it will execute this part. So they will check if b wait or b error or b last equal to 3 tick b 100. So in that case, it will come inside and it will execute. If previous address is not equal to ba, then $write error master address changed during wait state. So they are checking that during wait state, your master should not change the address, right? If if master is changing the address during that time, you should enable one flag. So that is what they are enabling. So you will get one display message at this time. This is the address that is changed. Okay. So that is what they are trying to say from this. So this is the protocol checker that they have implemented with the help of Verilog. Okay. Coming to the decoder, now they are trying to say the decoder functionality is a subset of the full required decoder functional protocol requirement. Okay.
Slave based.
Yeah. Okay. So during the reset state, no slave must be selected. Okay. Okay. Coming to directed random testing. Okay. Directed random testing means you are directing as well as you are randomizing the verification. Okay, suppose you want to generate a stimulus, it is random. Okay, but you can predict that this random test vector will hit in that specified area. Okay, you can say that random constraint, you are constraining that thing. So that is, you can say that directed random testing.
One doubt, in one test bench,
okay,
we can dollar display,
okay,
random,
dollar display random. Okay,
I think dollar random.
Okay, dollar random we have to use in order to randomize the things, right?
Yes. That means suppose we can pass data 5 times.
Right. Right.
Then the data are randomized. Yeah, because that is a 64. Suppose we assume 64.
Okay.
8-bit data.
Okay.
Randomized.
Okay, right.
That means depth is 64.
Okay, right. Right.
Then 0 to 63.
Okay.
Locations are.
Right.
Okay. Then 63 location, 6 addresses maximum.
Okay.
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 During random, dollar random, the compiler will automatically select some values 0, 1, or random means that is. I think
actually what they are trying to say from this randomization, so if I rephrase your question, okay, you are talking about something about FIFO. Okay, suppose you want to write some data inside the FIFO memory. So if the depth of the FIFO is 64, then how you will write? Okay, how to randomize the thing? So what you will do, when you are forcing the data from the bus function model, during that time you generate that data randomly. Use $random system task. Okay, that will return you a 32-bit value, signed value. Okay, so that value it will return. Okay, and that value you force through the write data port. Okay, so if you need to now address is there. Okay, if you are using $random address, so only we know that we are having 0 to 64 address.
63.
6 bits is there in order to represent 0 to 64. But address you need to generate between 0 to 64 only, right? You should not generate above 64 or less than 0, right? For that you can randomize your $random function, so that it will generate only the address between 0 to 64.
But data we
data you may be anything. Okay, for data no need to constrain. Only for control signals you need to constrain the things.
Data we can randomize because it is a data,
any raw data, it may be any raw data, no problem. So that you are randomizing. But control information you are constraining also, randomizing plus constraining. So that is what they are trying to say from directed testing. So we'll see what they are trying to say. The quality of the functional verification environment depend upon the stimulus that is applied to the DUT. So an exhaustive test vector can be written using all combination of input signals, but this is not feasible since it increases the simulation time tremendously. So what they are trying to say from this statement is, suppose like you say that your data bus width is 32 bit. Okay, so how many possible combination you can send? 2 raised to about 32. So it is not possible, it is not feasible, right? Your simulation, it will take too much simulation time. So instead of that, what they will do, they will do directed random testing. Okay, so what they are trying to say, in directed random testing, random address, data and control signals are driven onto the bus, and one and more bus protocol checker verify the protocol violation do not occur as the result of these cycles. What they are trying to say is, already you have implemented protocol checkers, right? So what you will do when you are generating a random data and pumping that data on the bus towards the slave side, during that time if you have created some wrong address or some wrong data, usually wrong control information, during that time your protocol checker can display an error, a wrong address generated, wrong control information, like that you will get some message. So that is what they are trying to say from this. Okay, now they are trying to say the test benches are directed in that test cycle generated and are not purely random but create cycle that stress the design in specific way. Yeah, what they are trying to say, what you are doing, you are trying to stress the design. Okay, you want to check when you are applying too much stress on the design, how your design is behaving, whether it is whether during that time your design is failed to give you the desired result or it is giving the desired result. Okay, suppose you are generating a too much traffic to the your design. Okay, so in that case how your design is behaving, whether your design is able to handle that traffic or not. Okay, so like you're applying burst traffic. Okay, so you are checking at extreme conditions when too much data or you are generating to that. Okay? So that is what they are trying, stress checking. You are stressing your design. Okay, so the pattern generator can be set to create specific transaction types such as read, write, read, modify, write and random sequence. For that you can write a task. For read you write task, for write you can write one task and just pass the values.